Alright, welcome back to another video. I think today I'll switch it up a little bit. Instead of doing some of the stuff that are sections you appear in math strategies, I'm going to start doing a couple of geometry lessons. So for those students that are in geometry A or B, hopefully some of this helps. I'll continue to try to mix it up a little. Sometimes I'll look at a student that's struggling in a section and then do a video for that. But unfortunately, by the time the video gets uploaded, it might not coincide with them getting help. So hopefully it helps students in the future. Alright, with that said, let's get to our video. Just a quick edit to this video. I decided to break the lesson into two separate videos. The whole thing was over 15 minutes, and I thought it'd be more beneficial for students just to watch it in two parts, since I didn't think most would want to sit through 15 minutes. The first part will be definitions and setting up what reflections are, and then the second video will be going more in depth about the rules of reflection and how to apply those to solve problems. So I hope you benefit from both videos. By the time you watch these, maybe both will be already submitted or uploaded, and you can watch them back to back if you want. Alright, today's quick lesson is going to be called Reflections, and this is part of the section in Geometry A called, in the sections under Geometric Transformations, and specifically Reflections. So let's first define a couple terms of what a geometric transformation is and what exactly a reflection is. Alright, before we start working with reflections in geometry, it's always key to know the terminology first. So let's go over some of the terminology that's going to be discussed in this section on reflections. So first we have what a geometric transformation is. Now, geometric transformation is just an operation that moves, flips, rotates, or enlarges or shrinks a shape. So if you have a shape that you have and you just move it, you can flip it, rotate it, enlarge it, shrink it. It's just moving a shape that you start with. So that's what a geometric transformation is. You're transforming that shape either to a different location, a different size, a different orientation. Next, there are basically four types of these transformations: rotation, translation, enlargement, and reflection. If I need to, I might make a separate video on each one of those types, but today we're just going to focus on reflection itself. So like I just mentioned, we're discussing reflection today. Reflection is just basically taking the shape and flipping it across the line of reflection. Line of reflection is the point where it's getting reflected upon. The best way to look at it is in terms of a mirror. You're flipping it over whatever line of reflection you can use. You can use like the x-axis, y-axis, y equals x. You can flip it over just about any line itself, and the relation to the shape to that line is the same, which I'll touch on in some of the other examples I will use. When it comes to reflections, there's a property that it has along with a couple other types of geometric transformations. It's called a rigid transformation. And all you have to remember what a rigid transformation is the shape itself stays the same. I can move the object, I can put it in a different orientation, I can throw it a different spot on your coordinate grid, but the size and shape of that object or shape will still stay the same. So the same sides will be the same, the angles will be the same. The only thing you're changing is the orientation of it or the placement of it. You're not changing the size. I'm not enlarging it or shrinking it. So reflection is one type of rigid transformation. Alright, so now we have some definitions out of the way quickly. I recommend writing these down if you're taking notes. These are something that should be in your notes, and they will help you answer some of the questions in your quizzes or assignments. So with that said, let's move on to more of a visual representation of what reflection is, and then I'm going to add on some rules that help you with reflections, that it's easier to, if you have to find out new coordinates of a new shape of their vertexes or points on that shape, there's some rules that you can follow that makes it really easy if you have it written down, memorized, or in your notes. Alright, with some of the terminology out of the way, let's see if we can look at a visual representation of what a reflection looks like. And we'll test my drawing skills here. So let's look at if I have a triangle centered, and put it right here. And if this was reflected across, let's say, the y-axis, this would be our line of reflection. It would be a mirror opposite. It would flip over that. So then it would look like this. The distance from here to here is the same. Every point here and every point here is the same distance from the line of reflection. So when you think of reflection, just think of it flipping over to the line of reflection. If I wanted to reflect it across the x-axis, this guy right here, it'd be the same. It would look like this. So it would be flipped this way. Remember the image we started with? Call that the pre-image. And then when we actually apply the transformation, in this case a reflection, the new shape or image is our image. In this case, this would be an image too. And we denote that as a prime. So if I label this as A, B, C, then our labeling for our image after we apply the reflection, our new points would be A prime, C prime, and B prime. So when we go from our pre-image to our image, the way we note that is this little accent mark over the coordinating vertex. We call that a prime. So remember, before we apply the image, before we apply the transformation, that's called our starting object is our pre-image. Once we apply that transformation, in this case a reflection, it becomes an image. And we denote that with these little prime keys. So we're going from here to here, and we use these guys.